Hi everyone. We are continuing now with the talk on functions as a form of revision for grade 12s before we get into the core of this topic at our level. Now we are discussing the hyperbola. We've just discussed the parabola and the straight line. And I'm reminding you again, in case you're just wandering around, of this concept of direct and indirect proportion. As I indicated, the hyperbola is essentially a reciprocal of the straight line, or you can say the hyperbola represents indirect proportion, whereas the straight line represents direct proportion. Now, what do we know? If two variables are in a direct proportion, in other words, if they are directly related, such that when one increases, the other increases, then the relationship is of this form. In this case, y depends on x. So as x values increase, we expect y values to increase. Now, in indirect proportion, in dealing with indirect proportion, the reverse happens. Whereas one value increases, the other decreases. What's interesting is that the product of those two values will always give you one value which is the same. In other words, x at a certain point on the graph and y at a certain point of the graph. When I multiply those two numbers, I will get the same answer as I will get when I take two different points on the graph. That's what indirect proportion means. So from the indirect proportion, making y the subject of the formula, we get this nice graph known as the hyperbola. And this graph immediately comes with a restriction that in this case, we do not want x to be 0, because division by 0 is not there in mathematics. We don't want to see ourselves dividing by 0. Now, again, this now becomes the mother function. We like playing around with things in maths. So it is no different with the hyperbola. We are actually going to play around by shifting this either to the left or right and either up, down. Like in the other functions, A still determines the shape of our graph. Then P and Q are still the same shifts. This remains our horizontal shift, and that remains our vertical shift. So let me write it again in the different form, not really different, but in a case where A is negative, so that you can remember what we have in that case. So if I'm going to draw let me just quickly draw my Cartesian plane. I will put both these graphs on the same set of axes so that you can see the effect of A. So I'll start by using red ink to draw this graph here where A is positive. When A is positive, we know that we are going to be in the first, right, as well as the third quadrant. And when A is negative, if I may use a different color, then we know we're gonna be in the second and the fourth quadrant. So maybe I should write there A is negative. Very important. This is one of the notations we use in maths. When we want to say A is negative, we simply write it this way and say A less than 0. If we say A is positive, we simply write it this way and say A greater than 0. And that makes sense from your number line. You know that all numbers to the right of 0 are positive and all numbers to the left of 0 are negative. So that's where this notation basically comes from. And we are going to discuss function notation so that you guys do not struggle with answering questions like x values when f of x and g of x, are greater or equal to 0, or where g of x is less than f of x. I will address this on a separate video. It is coming up. I am aware it's one of the questions or the concepts that are very difficult to understand. You find this is worth 2 marks and you find yourself solving equation that takes your time. These problems, we solve them by looking at a sketch, and I will show you exactly what to do when you are faced with such a question. So that's basically the hyperbola. Now, there's a special thing about the hyperbola. Remember, I put up this thing here to say we don't want x to be 0. And this is where the concept of asymptotes come from. In as much as I said there's a vertical shift and horizontal shift, correctly speaking, this is actually an asymptote. That is also an asymptote. And that is also an asymptote. That is also an asymptote. So wait a minute. How does parabola differ from straight line and the quadratic function, from the linear function and the quadratic function? Well, the only difference is that the parameters denote different things. In the linear function and the quadratic function, the parameters denoted shifts. In the hyperbola case, the parameters P and Q actually denote asymptotes. Let's have a look at this in a more, practical sense, in that we will take an example. Suppose I want to sketch a graph that says, well, y is 1 over x minus 1 plus 2. Then what this means is that at the point x equals to 1, I am going to draw an asymptote line. And at the point y equals to 2, let's assume that's 1, that's 2. Of course, this is not according to scale. You can see this is just a freehand drawing. You can see right there and there that there is a new set of x's that is kind of introduced. I look at that, my a there is what? Is positive, so I must be in this quadrant. Remember, asymptote are lines that you can never touch. If I were to find my y-intercept where x is 0, I'm going to have a minus 1 plus 2, which is going to give me a 1. So the line is going to intercept this. And if I'm to find the y-intercept, the x-intercept where y is 0, then I'm going to have a minus 2. So maybe I realized I should probably solve this so that you are not lost in what I'm saying. And then if I multiply by x minus 1 both sides, or what you guys refer to as cross multiplication, I will have something like that, minus 2x plus 2 equals to 1. And then taking this to the other side, or using the additive inverse, meaning subtracting 2 on both sides, I'm going to have minus 2x equals to minus 1. And you can see right there and there that x should be a half. And now if I were to plot my graph, it should pass through this point, and there are my intercepts, and there is the graph. And one of the questions that really do appear in grade 12, sometimes you are asked to draw a graph, sometimes you are given a graph and you are asked to bring out these parameters. What is x, what is y, and what is p, what is q, what is a, determine the value of k, and all of that. I will do some examples looking into that here. I'm just dealing with the theory of graphs, what you need to understand about the parameters in each graph. And as far as the parabola is concerned, I will leave it here. I will discuss things like the domain, the range, and as I said, and stuff like this, fx greater than in a separate video so that you can understand them better. In the next video, I'm discussing the exponential function, which is the last algebraic function that you have seen between grade 10 and 11. Then I will discuss also the inverse function. That's where the logarithmic function is going to come in. As a matter of fact, there is another thing actually that I should kind of show you, something very cool about the hyperbola. And I will do that, of course, when I get into examples. Right now, I'm just introducing the concept, or so to say, reminding you of what you already know and what you should know if you do not know, so that you can understand the examples as I go through them in the upcoming videos. I'll leave it here as we move on to the next function, the exponential function. Cheers.